Good morning to all of you. I welcomes to all in our lecture series on quantum mechanics. Today we are going to discuss about spreading of Gaussian wave packet. So before we have to do the mathematical derivations regarding this topic, first we have to just somewhat discuss about what is wave packet and what is Gaussian function. That means how a wave packet can be represented with the help of the Gaussian wave function. So may you have been remembered that from the very beginning of our discussion on the quantum mechanics, I can show you, and you also can check your note, that the wave packet looks like this. That means this packet is sum of or this can be constructed due to superpositions of numbers of waves. So this is nothing but called as the wave packet, and the particle will be present at the center of this packet, and the highest amplitude moving with group velocity, and all the separated waves having slightly different frequency moving with different velocities in this envelope, or it can be called as also envelope, wave packet envelope. Okay. This envelope represents the so-called quantum particle. So here we are going to be discuss that if this packet is going to be moved in the free space, or a particle is moving in a free space, its shape and size or geometry of this wave packet is going to be destroyed or is going to be changed or not, that we are going to be discuss. Again I repeat that in this topic, whatever we are going to be discuss in our spreading of Gaussian wave packet, in this topic we are going to be discuss that if the wave packet is moving, suppose along x-axis, here we are going to discuss only on along x-axis. Okay, along x-axis, then its geometry or its shape is going to be changed or not, that we are going to be discuss. Okay, so I told that before we have to start our mathematical derivation, we just discussed somewhat about the wave packet, but you can found that this upper half, or it is called as the real part of this wave packet, this, or if only this part or the real part and its corresponding imaginary part. Okay, so if only I am going to consider the real part of this wave packet, it will be looks like this. I am going to be draw over here. It will be looks like this. That means the particle will be here and its real part will be like this. Okay, will be like this. So now if we want to derive its mathematical expressions, that how it is going to be behave if this wave packet is going to be moved in the space, or a particle, this particle here is the particle, if here the particle is going to be moved freely in the space, then what will be its geometry of this wave like structure or peak like structure, you can say. So this is looks like a peak which is symmetric, having the symmetry to left side and right side of the particle wherever it is situated. So here particle will be there, means this side and this side, the wave function or this graph or this geometry is symmetry. So now before we have to analyze its behavior in the space where it will be travel, first we have to represent this peak with a mathematical expression. So this peak will be represented with a in general, or it is one, you can say it is a famous function, it is well known function, that is Gaussian function, that is Gaussian function, Gaussian function, Gaussian function, Gaussian function. And that Gaussian function in generalized, in general, the Gaussian function can be written as like this: z equal to 1 by sigma 2 pi root over into e to the power. In general, it is written as like this: x minus x dash square divided by 2 sigma square. Okay, so Gaussian function, the general Gaussian function can be is in this form. So if suppose we are going to take as this much is one constant, so it can be very simply, it can be represented as some constant into e to the power x minus x dash square by some constant. Suppose this is k1, this is k2. So this function, if we are going to be draw, then we are going to be found that this type of graph will be found if we are going to draw this function, and here this point will be x dash. Okay, so now here wave packet, or the so called your real part of the wave packet is the similar structure or similar shape with the Gaussian wave function. Now this peak or this wave function or this real part of the wave packet can be represented by the Gaussian function. That's it. Okay, now so here particle is situated at x dash. Suppose we are going to be consider the particle will be situated at along x axis, it is moving, and it is situated at 0 at the origin, at origin. So here x equal to x dash. So x equal to origin. If we want to, or we are going to be write the Gaussian function of the particle, whose real part of the wave function will be like this, and the particle suppose will be at origin, then its Gaussian function will be written as g equal to sigma 2 pi root over into e to the power minus x square by 2 sigma square. These things no need to write in your note. These things you have been studied in detail in your first semester or second semester, like that. First semester you have been studied, so you can follow that note. No need to write these functions. Only you just remember, or only you just revise with your note. No problem to write over here. If you want, you can write these things in your note. No problem. So now this packet, which represents that the particle is at origin, and its Gaussian function will be this one, because here x dash will be equal to 0. Okay, so that in very simple manner, if you want to remember the Gaussian function, that it will be the Gaussian function very simple manner, or very simple way, it will be e to the power minus x square. That's it. The very simple representation of the Gaussian function is this one. But here sigma have some physical meaning that we have to be consider whenever we have to discuss the Gaussian function. But if we want to remember what do you mean by the Gaussian function, it will be exponent to the power minus x square. You just draw in your graph in your graph, then you are going to found that this type of shape will be appear. So as our wave function, as our wave packet and its real part is looks like a peak, and this peak can be represented by the Gaussian function. Okay, so hence this topic name is spreading of Gaussian wave packet. The means the wave packet is represented by the Gaussian function, and then what condition this packet or this Gaussian function which represents the wave packet is going to be spread, that we are going to be discuss the physical things and the corresponding mathematical things also. So may you remember, I also taught in your first semester that if this sigma tends to 0, if this sigma tends to 0, if the sigma tends to 0, then this peak height is going to be maximum at this point, because you can see this is 0 means 1 by 0 is tends to infinite. So when the sigma tends to 0, this peak height will be maximum. The meaning of the physical meaning of this sigma here will be that one. So if the sigma will be increased, suppose for this peak, this is the our equation, right? Suppose now we are going to consider that another peak like this, it is like this. Suppose another peak is like this, which have peak decreased and spreading and width also increased. For this you can found that the sigma will be increased. Okay, if sigma will be increased, this envelope or this peak height will be reduced and the peak width also increase. So as sigma will be increased, the so-called peak is going to be spread out with decrease of its peak height. Okay, so this is the physical significance of sigma. Okay, so now we are going to be discuss our today's topic with mathematical derivation. So first this topic is I divided into two parts. One is propagation of wave packet without distortion, and another video you are going to be found that propagation of wave packet with distortion. Okay, so today we are going to be discuss the propagation of wave packet with distortion, without distortion. So actually the basic things I have been written over here, you can write in your note, it will be helpful for your exam. That is time evolution of wave packets. That means with time how the wave packets behaves when it will be move in the space, with time how it will be behaves. Somewhat things I have been written, you can write in your note. So here I written, in this topic we have to analyze when does the wave packet may or may not spread in the space. If one know the initial wave packet or amplitude, after time t, psi xt can be determined from the integral this one, and here omega and phi k are the angular frequency and amplitude respectively, and the spreading or non-spreading of the packet is decided by the wave function or the function omega k. How it is, we are going to be discussed. So today we are going to discuss in this video propagation of wave packet without distortion. Okay, sorry, or non-dispersive propagation. Okay, in general form, the wave function of the particle moving freely along x-axis is, we know it is from our beginning of the discussion of the quantum mechanics, I have been derived that the wave function, general wave function, will be represented by this one psi xt. See, psi xt will be 1 by 2 pi root over ak e to the I k x minus omega t dk. From the beginning you can check your note. Okay, so here instead of ak, the so called amplitude, it has been written as phi k. Okay, here, but omega is proportional to wave number. Okay, because we know that omega, angular frequency is the omega is equal to 2 pi by t. 2 pi by t, this is the angular frequency. So it can be written as 2 pi by lambda into lambda by t. Okay, and 2 pi by lambda will be nothing but k, and this lambda by 2 will be v, right? So here omega, if v is the constant, suppose wave packet moving, one wave packet, it is moving along x-axis with a constant velocity, suppose with a constant velocity, then here v is constant. If v is constant, then we can write v is a omega will be proportional to k. So hence it is written in that way, that omega is proportional to the wave number k, that is omega proportional to k, and omega equal to v0 k. Here v0 is the constant, what I discussed. v0 is constant of a proportionality but dimension of the velocity. You can see if this particle or the wave packet is moving along x-axis with a constant velocity, then we can say that omega or angular frequency is proportional to the wave number. Now put omega is equal to v0 k in equation number 1. This is our equation number 1. Now we are going to put, instead of omega will be v0 k. So if we are going to do so, then the psi xt will be this one. This is equation number 2. Okay, so this can be written as k can be taken outside, so 1 by 2 pi phi k e to the I k x minus v0 t dk. Okay, or it can be written as psi 0 x minus v0 t. Okay, because from equation number 2 we can found that at time t equal to 0, this will be psi 0 x or psi x0. If we are going to consider, then it will be t will be 0, means this part will be 0, and it will be e to the power I kx into dk. So psi 0 means at time t equal to 0, psi x0, it will be psi x0, or it can be written as psi x0. Okay, psi x0, or it will be psi 0x will be phi k e to the I kx dk. So here if we are going to put, instead of x will be x minus vt, then we are going to found this equation. Okay, hence this can be written as psi 0 x minus v0 t. So here psi xt is identical with psi 0 x minus vt. Okay, so that means we found that psi xt will be equal to psi 0 x minus v0 t. Okay, so that is the wave packet at time t is identical with the initial form. So wave packet travels along the x-axis with constant velocity v0 without distortion. It means that whenever the particle will moving with a constant velocity, then the wave packet will be without distortion. The wave packet could not be distorted, could not be changed. That means if the particle is moving without any potential or without any force, suppose this particle is moving this is the wave packet moving along x-axis with a constant velocity, that means there is no force on this, or there is no potential on this particle. If suppose we are going to consider any external force will be applied on this particle, then its velocity is going to be changed. However, if its velocity not changed, that means the wave packet is on non-distorted or without distortion, it is moving along x-axis. Okay. It is well known that omega k is the smooth function of k. So for further simplification of equation number 2, so equation number 2, we found that for this condition, if the particle is moving along x-axis without any distortion, means it is moving with a constant velocity, and that equation number 2 also can be further simplification by considering Taylor series of omega k about k0. So okay, so equation number 2 is going to be further simplification by considering omega k, Taylor series of omega k about k0. About k0. So now expand omega k about k0 using Taylor series. We can found that omega k0 so omega will be equal to omega k0 plus k minus k0 by 1 factorial d omega by dk at k equal to k0, and k minus k0 square by 2 factorial d square omega by dk square at k equal to k0, and neglecting the higher order because k minus k0 is very small. So k minus k0 of higher order can be neglected. So this will be, so omega k value will be considered up to third term. This is equation number 3, and we know that Vg or the groove velocity is nothing but d omega by dk at k equal to k0, and here we considered alpha equal to 1 by 2 d omega square by dk square at k equal to k0, and here k minus k0 is del k is the small, hence a higher order of k minus k0 will be neglected, what I told. The equation number 1, now if we have to put this value, this omega k value, this one in equation number 1, the equation number 1 will be the equation number 1 is nothing but pi here you have to put, okay, hence the equation number 1 will be this much, psi xt equal to 1 by 2 pi minus infinite to infinite pi k minus k0 e to the power I k minus k0 x minus omega k0, here omega is the function of k0, okay, plus k minus k0 vg into t. So next it has further simplification only, okay. By further simplification we can found 1 by 2 pi root over, and this will be e to the power I k0 this much x minus omega k0 by k 0 t, and this much into this term also multiplied into phi k minus k0 e to the power I k0 x minus vgt dk, okay. So is equal to e to the power I k0 x minus, we know that omega by k is nothing but phase velocity, so phase velocity vp into t, and other terms have been written in this way, that 1 by 2 pi will be here, minus infinity to plus infinity, and phi k minus k0 e to the power I k minus k0 x minus v gt into dk into e to the power I k0 into x minus v gt. Okay. So that implies psi xt will be e to the power I k0 x minus vpt psi 0 x minus vgt into e to the power minus I k0 x minus vgt. Let this is equation number 4. So here psi 0 x minus vgt is nothing but this one, this much value. Okay. So here psi 0 x minus vgt is this much, or it can be written as phi q e to the power I q x minus vgt dq by considering k minus k0 as q and dq equal to dk. Okay. Then from equation number 4, see, from equation number 4, this one, from equation number 4 means psi x vgt, from equation, sorry, this one, for equation number 4, this one, if we are going to take its psi xt into psi star xt, psi xt into psi star xt, then how much we are going to get? You just watch it. See, this is e to the power I something, and its complex conjugate will be minus I k0 this much. Here it is minus I k0 something, and its complex conjugate will be plus. So when it will multiply that term, this e to the power this term and e to the power this term, and we are going to get psi 0 xt x minus vgt mod square. Again I am going to repeat these things carefully, you have to watch. See, suppose we are going to consider psi star xt first, psi star xt. So it will be how much? It will be e to the power minus I of this one, psi 0 x minus vgt into e to the power plus I0 of this one. Now I am going to multiply psi xt and psi mod xt. So here is a plus, for this one it will be minus. So if I am going to multiply, it will be e to the power 0 1. Likewise for this term it will be e to the power 0 1. Now it will be psi 0 x minus vgt mod square. Same thing I have been written over here. From equation number 4 we can found psi xt mod square will be equal to psi 0 x minus vgt mod square. Okay. Let this is equation number 6. So the equation number 4 represents a wave packet whose peak travels with velocity vg while the individual waves propagates inside the envelope with phase velocity vp. You can easily found from equation number 4 that this psi xt is nothing but a wave function. Okay, if we are going to consider this wave function, that means a pulse is moving along x-axis. A pulse is moving along x-axis, or if we are going to consider psi into psi star or psi mod square, then it will looks like this one, a wave packet. So in a wave packet is moving, or if we are going to consider only the real part psi, it is moving along x-axis, and its peak is moving with vg, the so-called group velocity, and all the waves, because we know that a wave function of a particle is nothing but the superimpose of number of wave functions. Yes, the wave function is of a particle is nothing but superimpose of number of waves of slightly different frequency. So inside this envelope many waves are there. So this peak is moving with velocity vg, and the waves which are inside this envelope, they are moving with the phase velocity Vp. Okay, with average velocity Vp that we have been discussed in our very beginning of the videos, that is difference between Vg, group velocity, and phase velocity. You can just, if you want, you can just watch that video and that topic. Okay, so here the equation 4 represents a wave packet whose peak travels with velocity Vg while individual waves propagates inside the envelope with phase velocity Vp. Here phase velocity, some one average velocity of all the individual waves. So Vg, we know that represents the velocity of the packet's peak or particle. So we know that one. So this is the peak, and this is peak, and its corresponding position is nothing but called as the particle. This is called the particle, and at the particle position, the height of the peak is maximum, or this peak is moving with the velocity Vg. That means, or we can say that the particle is moving with the group velocity. Hence psi 0 x minus Vgt, that is equation number 5. That is equation number 5. That is equation number 5. This one. This equation number 5, which is a curve that travels to right with a velocity Vg without deformation. So here we found that this is one curve, you can say, or one envelope, you can say, or you can say that at a peak which is travels with the velocity Vg without a deformation. So if the packet is initially Gaussian, it will remain, although it propagates without change in shape. So the wave packet propagates undistorted and undergoes a uniform translational motion. So from here we have been concluded one thing: without any external force, the velocity of wave packet is not going to be changed. This wave packet will be moved with a constant velocity, and this velocity of the wave packet or the particle will be represented by Vg, and each and every waves which are inside this packet will be moved with average velocity, that is called as the Vp, that is called the phase velocity. So about phase velocity and group velocity, regarding phase velocity, group velocity video, you can watch once again if you want. Okay, so next video we are going to be discuss, again I am going to say that if a particle is moving in a non-dispersive medium in which there is no external force, then there is no deformation occurs of the wave packet. Okay, so this is the all about propagation of wave packet without distortion or in the non-dispersive propagation. Next we have to discuss in our next video, that is propagation of a wave packet with distortion or spreading of Gaussian wave packet. Okay, so thank you so much for watching this video. Thank you.